Welcome everybody to our video solution to problem 1b from quiz 8. We have another series that we want to detect whether it converges or diverges. And this one, you have a lot of different methods. You could use a limit comparison test, you could do a comparison test, but the way you should do this problem isn't to go to any of the complicated tests, but really to go back to the most important thing we know, which is that a series will not converge unless the underlying sequence converges to 0. So the underlying sequence, which is 5n plus 3 over 3n plus 1, we can ask what this converges to. And whenever you have a nice rational function of n, it's really pretty easy to figure out what it's going to converge to. You look in the numerator for the highest power of n, and you look in the denominator for the highest power of n. And if the numerator and the denominator have the same highest powers, which they do in this case, then this sequence will converge to the ratio of their coefficients. So in this case, you get 5 over 3. Okay, maybe you don't believe me. Okay, we can check. We say, okay, what's the limit as n goes to infinity? 5n plus 3 over 3n plus 1. And we're going to factor an n out of the top and the bottom. So this will be the limit as n goes to infinity of n times 5 plus 3 over n times 3 plus 1 over n. Of course, the n's cancel. Right? N is going to infinity. We don't have to worry about it being 0. And so I'm left with 5 plus 3 over n over 3 plus 1 over n. And of course, the 3 over n and the 1 over n both converge to 0 as n goes to infinity. And thus we're left with 5 plus 0 over 3 plus 0, which is 5 over 3. All right. So this is the way we want to think about it. And now, since the underlying sequence does not converge to 0, it does converge, right, to 5/3, but that's not helpful for series convergence. Okay. So this implies, by the non-vanishing sequence test, okay, so we need the sequence to eventually vanish, that is, go to 0. This implies that the series n goes from 7 to infinity, 5n plus 3 over 3n plus 1 diverges. Okay. Incidentally, in case you're wondering, what if the numerator had been bigger? Right? That is, the power of n was larger than the power of n in the denominator. That is always going to go off to infinity or negative infinity. And if the denominator has the larger power of n, then the sequence will always converge to 0. Okay, so that's actually the only way it's going to happen, right? Which shouldn't be too surprising, right? You even have like the harmonic series, where here the denominator is bigger, right, than the numerator. The underlying sequence goes to 0, but the series diverges. So even in this case, the series is going to diverge. So if you make it like worse than this, so if you make these have the same degrees or even the top bigger, well, of course it's going to have to diverge because it's going to be bigger. Okay, so don't whip out any of the big guns for this problem. Just look at the sequence and say, hey, it doesn't converge to 0. We got no hope here for the series.